Now, this next implication is one of the hardest things for us to completely understand, and it's because our experience with it absolutely does not match the reality. But to explain it, I'm going to give you a hypothetical, very strange thing. Let's say an alien comes from the planet Gorplax. The alien from the planet Gorplax is very unusual, and he's a nice fellow, so we decided to take him to a soccer game because that is the international sport. Excuse my bad drawing, really not my thing. And so he is going to watch the ball being kicked around the place. So he sees a ball kicked this way. He sees a ball kicked this way. And he has a really weird problem. His problem, simply put, is this. He cannot see in this direction. He can only see this direction, right? So from his perspective, people are only running this way. And so when a person runs this way but changes direction, he thinks they're only running this far, right? He'd only see this particular direction. And so he would be a little confused by the fact that the person would slow down while appearing to run the same thing. His body position might change some, but his bottom line is he would think, gee, the guy just slowed down. In fact, if the guy starts running this way, he would look like he's running in place. The time is going on, but he's not going anywhere. Okay? So from his perspective, the guy would no longer be moving. And so he would find the sport very strange because at times people are running the way they should be. At times people are not running the way they should be, running slower, and sometimes they're not running at all, even though they look like they're running. And so he would come away from the sport thinking there's something strange about the sport of soccer, something that involves some sort of strange thing where when you're sitting in one place, you actually pretend like you're moving in a direction. What if we can't see a direction? Well, we can see all the directions, Mr. Esney. I woke up this morning. I can see left, right. I can see forward, back, and I can see up, down, right? I can see coming out of the board towards my forehead. I can see all these directions. There's all the directions that are possible I could see. What if you can't? Well, explain. Well, here's something interesting. If you look carefully at the length contraction, and you move it around a little bit, it looks an awful lot like the time contraction. In fact, they look the same. Why do they look the same? Is it possible that time is another dimension, and then a direction we're traveling in? Well, okay. Yeah, but if I run really fast this way, okay, how fast am I moving in the direction of time is the question. And the answer is really interesting. It says, well, since these two are dependent on each other, the faster I run in one direction, the less faster I run in the other direction. In other words, my clock goes slower when I run in a direction. Well, that's what relativity says. We already found that. It's proportional to the to Pythagoras. Which means when I'm running this way, I'm running less fast in the time direction. But I am running in the time direction because I can't stop my time direction. The only way to stop the time direction is to run the speed of light in a direction. In that case, my time direction becomes not running at all in that direction. Oh. It gets worse. There's another implication. When are you moving the fastest? When you're sitting in a chair minding your own business, not going anywhere. But you are. You're going full speed at the speed of light in the time direction. And so when you play this game, you quickly come to the conclusion that time is just a dimension like the other ones. Has been all along. The problem with the time dimension is we are the people at the soccer game. We are the aliens. We can't see how fast we're traveling in time direction. Sitting in this chair as I am right now, let me see if I can myself sitting in the chair. Should have been prepared for this. Sorry. light's coming up. Oh, here we go. Oh, close. Okay. So sitting as I am in the time dimension right now, I'm traveling at the speed of light in the time direction. I just don't know it. I kind of do because I perceive time. But if I sit here long enough, I notice things are moving around me. So I'm going to other places in the time direction. In fact, when I start to move, I slow down my time dimension. I'm always slower in the time direction. Not noticing a very small amount because I'm not going very, because the fastness I'm going is nowhere near the speed of light. It's getting closer to the speed of light, though. My time dimension goes slower and slower. My clocks on my walls slow down. And so, oh, it's going to record me. I didn't really want it to do that. All right, whatever. So, this is the situation, okay? You are always traveling, according to this idea, at the speed of light. Always. You just change directions. That's all you do your whole entire life. I get in my car, start driving east. Okay, now I'm going east a little bit and really fast in the time direction. If I drive fast enough east, like near the speed of light, my time direction shrinks down to a point where other people outside of me are like, hey, you're moving really slow in your car. So time is a dimension. That means that things like gravity warps time. Why is it that when we say you don't have to write your own reference frame when you're accelerating? Well, if I'm accelerating, I'm bending time. Guaranteed my experience will be messed up. Reason why things look different to me time-wise is because the ball isn't doing what it's supposed to do. Well, the ball is doing what it's supposed to do. It's traveling in normal direction. I am watching it with time being changed, the time direction being changed, which caused me to look at the ball and go, oh, that thing's going faster and faster. It's okay. I have a right to my reference frame unless I'm accelerating. Why? Because I'm in the process of bending the space around me when I look at a ball and I'm accelerating. It's not the ball's fault, my fault. I'm the one that's in the weird reference frame. Yeah. Anyway, all you really need to know about this is that time is a dimension, just like left, right, up, down, sideways. And if I start traveling faster in another direction, I have to decrease my speed in the time dimension because I can't go fast the speed of light. It's not possible. And time basically sucks up the rest of my velocity. So there's always a component in the time direction. Never drawn it on the board, but it is a true thing. Okay, and so therefore, as a bit of fuzziness, that has some really strange echoings to how we look at the universe. It should. But again, who cares? I'm driving my car, time on my watch goes by. I don't spend a lot of time thinking about, hey, time is acting strangely because I'm accelerating. Okay, fine. I can do all my classical mechanics as long as I'm not anywhere near the speed of light. I can do all my classical mechanics. It's not a big deal. The time is a dimension, and so therefore, it is not impossible that in your lifetime we'll spend some time experimenting with time and traveling in time in ways that have nothing to do with that seem more similar to X, Y, and Z. People right now are spending millions and millions, and I think it's actually billions of dollars on trying to figure out how to travel better in the time dimension, have better control over your time dimension speed, rather than it being a result of the component that is not in the time direction. Okay. All right. Fun. All right, we're done with this.